Hi, my name is Casey Martinez, founder and CEO of Clean Incentive. Today I'd like to share with you the Granular Registry, incorporating energy storage into corporate procurement. Our goal is to expand the revenue stack for standalone battery assets. And we do that by adding carbon arbitrage and granular certificate arbitrage to the stack. And this can be achieved in a number of ways, but essentially it's charging when grid emissions are low or when carbon-free energy is abundant, and discharging when grid emissions are high and CFE is scarce. So the overall strategy here is to take a standalone battery, and step one is to assess its dispatch, time, and impact. So what you see here are hourly RECs, also called granular certificates, colored by carbon impact. And in this example, red is low impact and green is high impact. So once you've analyzed the dispatch profile of a battery asset, then you can move on to step two, which is to cancel the original GCs that are being shifted from the red hours, the charging hours, and issue storage GCs in the discharging hours. And then the battery operator would essentially sell the storage GCs either in a merchant or a forward contract for this GC arbitrage opportunity. So there are many contract structures that can be used in this opportunity, just like REC agreements in the renewable space. What I want to talk about today is this fully contracted bilateral virtual hybrid, where the supplier of GCs to be shifted is the same corporate buyer or utility as the buyer of the GCs. So the way this works is that the CFE generator on the lower left will submit hourly meter data to both the REC registry, the normal way RECs are issued, and to the granular registry. And we would convert those RECs to granular certificates. So the RECs that are not to be shifted will be assigned to the corporate off-taker's account. But a storage operator will be also share hourly meter data with the registry to be assessed. So that dispatch assessment is done, and then we identify the GCs that can be shifted by this battery. We assess the net impact of the GCs and the battery dispatch, and then we go ahead and move forward to cancel the supplied GCs for shifting and issue the storage GCs, which are then transferred to the corporate off-taker. So essentially what we're doing here is we're stripping away the GCs that are issued in a PPA and converting some of them to be higher impact or in more desirable hours. So working through an example, here is a solar farm in CAISO, which has an extreme duck curve showing excess solar generation in the afternoon. And so, in this case, there's nuclear as base load, a lot of solar, some hydro, and some wind. But if you look at the flat load capacity demand in one solar farm PPA, you will see that you have hours in the afternoon that exceed your needs, so that's oversupply hours, and then you have demand hours where you don't have enough solar energy to meet your flat load. So what we would do is pair the BESS storage project to this solar project. So in the lower graph, you see an aggregation of the battery charging hours and the battery discharging hours to see how it aligns. And in this example, it aligns well with the solar project in California. So the overall dispatch profile looks good, and so then we look at the actual hours of activity. And you see here the blue is the solar farm and the red is the battery. And you can see variations, obviously, from clouds and solar resource, and then also variations in dispatch based on what dispatch optimization the battery is doing. So by shifting those excess solar RECs from the afternoon to the evening, you can see here that the before profile of blue solar generation is now modified to be the red profile, which is taking that solar energy and shifting it into the evening. And that increases the CFE score of the corporate off-taker for this new virtual hybrid farm. So many are in the industry are concerned about carbon impact, and our solution to this problem is to pass along the net impact of the battery to the storage GCs. So what that means is, starting on the left, the battery will have a certain amount of induced emissions from charging. And in the case of this CAISO example, a lot more avoided emissions from discharging. So the best net impact is abating. So in this case, if the solar GC impact is enhanced or it grows when it's shifted. So what this looks like is solar RECs in the afternoon would have very little carbon impact because of the oversupply of solar, and shifting to the evening hours would create much larger impact GCs. And so for example, you would take 100 solar GCs at 0 MER, so marginal emissions rates. You'd be applying the battery, which has charging, losses, and discharged energy, which result in a 0.3 improvement or abatement per megawatt hour of discharged energy. And so overall, in this example, the net impact is 24 tons of CO2. Well, that is then applied to the 80 new storage GCs that are shifted. Because of the round trip efficiency, 100 solar GCs go in and 80 come out, but the 80 that come out are higher impact. So you've converted 100 zero impact GCs to 80.3 impact, higher impact. But also the opposite can be true with net emissive batteries. So in cases where there's not as much of a duck curve or a seasonal variation in marginal emissions rates, a lot of times the discharge impact is less than the charging impact. So the best net impact is emissive. In this case, you can still shift GCs in time, but you're going to be reducing the carbon impact of these GCs. And so in this case, you would still start with 100, call them medium impact solar GCs. But because the best net impact is negative, the result is you're going to be having a lower impact GCs at the end. So the Clean Incentive Platform consists of two parts. The registry for granular certificates that's open to be used by all corporates and marketplaces and software providers. And then the separate platform is the marketplace with impact management tools. So this is where corporations can manage their certificates, add load data, and help them reach their goals of 24/7 hourly matching or impact matching. Thank you very much.